Good morning. Listen. So we have started the unit number first, that is the production of pressure, temperature, measurement. In that, basic concepts are clear: mechanical measurement, what is meant by measurement, why they are used, and requirement of measurement. Okay. Then our first part is generalized measurement system. Means any instrument or any equipment based on these block diagram. Means physical quantity to be measured, primary sensing element, variable conversion element, variable manipulation element, data transmission element, data processing element, data presenting element or display, and last one is the observer. Okay. Then instrument characteristics, they are divided into two categories. First one is static characteristics and second one is the dynamic characteristics. Statics means based on the static characteristics. Means static means stable. You have to take the dimension, not respect to the time. And dynamic means you have to take the dimension with respect to the time. Okay. Then see the different definition in that: readability, list count, range, error, calibration, hysteresis, sensitivity, resolution, threshold, repeatability, reproducibility, and linearity. Okay. Then we are going to see the sensors and transducers. Then classification of transducers, then function of transducers, and started the new point, that is a temperature measurement. In that, there are 4 sub-instruments used for measuring the temperature. First one is the thermometer, RTD, thermistor, and thermocouple. I think thermometer is completed. Also, second thermocouple is completed. So today we have started the RTD. RTD means resistance temperature detected. Okay. See, the range of this instrument is -200 degrees Celsius to 500 degrees Celsius.
Hello, sir.
So give the heading.
Hello.
RTD resistance temperature detector and draw this diagram. Give the heading resistance temperature detector.
Hello,
RTD. Resistance temperature detector. RTD. And draw this diagram. Yes, sir, please change the slide. Okay. Same problem is there.
Hello, sir.
Harushi.
Screen is not visible, sir.
So just check.
Yes, sir. Yes. Now visible.
Okay. So today started the new point, which is resistance temperature detector. Give the heading resistance temperature detected in bracket RTD and draw this diagram. Okay. See. Balance. Resistance temperature detector means you have to use some resistance to detect the temperature in laboratory type and industrial type. Laboratory type, somewhat the range will be minimum compared to the industrial type. This RTD based on the Wheatstone bridge circuit. Okay, Wheatstone bridge circuit means R1, R2, R3, and last one is the RT means R4. They are the four resistance. If two resistance are connected in series and two are connected in series, means R1 and R2 connected in one line, and R3 and RT means R4 are opposite side, means R1, R2 and R3 and RT or R4 are in series. This Wheatstone bridge circuit is a null, means transfer to the energy is equal to the output of this bridge circuit, or collected the voltage VD. ठीक आहे. Wheatstone bridge circuit कशावर डिपेंड असतं? चार रेजिस्टन्स असतात त्याच्यामध्ये, दोन सिरीज मध्ये जोडलेले असतात, दोन सिरीज मध्ये जोडलेले असतात. ठीक आहे. R1 R2 सिरीज मध्ये जोडलेले आहेत आणि R3 आणि RT किंवा R4 हे सिरीज मध्ये जोडलेले आहेत. तर पहिले R1 R2 आणि R3 R4 ह्या दोघांचं पॅरलल कनेक्शन केलं तर त्याच्यामधून जो काय पॉवर सप्लाय देणार आहे तो असणार आहे 0, आपला नल असणार आहे. जेवढा आपण इनपुट देईल तेवढा आपल्याला आउटपुट मिळेल. म्हणजे इनपुट इज इक्वल टू आउटपुट. ही आहे आरटीडी ची बेसिक कन्सेप्ट. आरटीडी बेस्ड ऑन द विस्टॉन ब्रिज सर्किट. ठीक आहे. आता इथं रेजिस्टन्स इलेमेंट, हियर रेजिस्टन्स इलेमेंट मीन्स दीज इलेमेंट सेन्सिंग द टेम्परेचर व्हेरिएशन्स. टेम्परेचर जे काही व्हेरिएशन्स होणार आहे ते इथं सेन्स केले जाणार आहे. ठीक आहे. When you are going to use in laboratory for education purpose, we are going to use the laboratory for education purpose to measuring the temperature. We are going to select the resistance, that is laboratory type. In laboratory type means as a thermometer type. For example, see, this is the glass or Pyrex bulb, and in that platinum sensing coil is there. Platinum sensing coil sense the temperature changes of temperature variation with this help of resistance element, and this resistance element transfer this changing the temperature to the Wheatstone bridge, and Wheatstone bridge noted the output voltage here. Clear? Then write down the thermometer compresses a resistance element. The thermometer compresses a resistance element or bulb the thermometer compresses a resistance element or bulb suitable electric leads and indicating recording suitable electrical leads and indicating recording or resistance measuring instrument. Full stop and next line. The resistance element is usually in the form of coil. The resistance element is usually in the form of coil of very fine platinum, nickel or copper, platinum, nickel or copper, wound non-conductively into an insulating ceramic former. Which is protected externally by a metal shell. So tell me why here used resistance material as a platinum, nickel or copper. Platinum, nickel आणि copper हेच मेटल काय यूज केलं जातं? स्टील किंवा दुसरं काही कास्ट आयर्न वगैरे काय यूज केलं जातं?
Sir, they are conductors.
Repeat. Your answer is correct. Please repeat it.
So they are very sensitive to temperature and electric.
Okay. They are very sensitive to detect temperature or variation in temperature. Another one, platinum, nickel and copper. Why they are used to detect the temperature variations? Basic concept is platinum, nickel and copper is a thermal conductivity material. Means they can sense or they can detect or they can find out the small variation recorded in the temperature. That's why these materials are used. Here, to stop, then write down third point. The change in resistance is usually measured. The change in resistance is usually measured by a Wheatstone bridge, which may be used, either in the null in bracket balanced condition, or in the deflection in bracket out of balance condition. And temperature range is minus 200 degrees Celsius to plus 500 degrees Celsius. Okay. Then advantages of RTD. Advantages: simplicity and accuracy of operation. Second, possibility of easy installation and replacement of sensitive bulbs. Means you have to use the laboratory type and industry type resistance. Easy check on the accuracy of the measuring circuit by substituting a standard resistance for the resistance level. And disadvantages: resistance change due to temperature changes of measuring resistors. And possibility of current leakage between the resistance element and the ground. This system RTD are not in evacuated tube or evacuated container. That's why the leakage of resistance element, leakage of current due to the ground. That's why giving the output or answer is somewhat type incorrect. This is the main disadvantages related to RTD. Okay. Then next and last point or last instrument of temperature measurement is thermistor. Give the heading thermistors. And draw this diagram. Okay. In thermistors, basically thermistors are used to measuring the small temperature changes. Its range is -100 degrees Celsius to +300 degrees Celsius. Compared to the RTD, resistant temperature detector, here in RTD, we are going to use the input supply, and here thermistor, we are going to use the battery for circulating the electric current. Same thing is that variable resistance means you have to use the laboratory or industry. You are going to select the different variable resistance to detect the or sense the temperature, and this sensing temperature is compared to the input supply, that is battery, and this comparison input supply and variable sensing temperature are compared or measured with the help of thermistor. Okay, here thermistor changes resistance with temperature changes. They are temperature dependent resistance. They are perfectly suited for scenario where one specific temperature needs to be maintained. Underline, one specific temperature needs to be maintained. They are sensitive to small changes in temperature. They can measure liquid, gas, or solid depending on the type of thermistor. Clear? These thermometers are used to measure the small changes in temperature, where one specific temperature needs to be maintained. म्हणजे जिथं टेम्परेचर जास्त व्हेरी होत नाही, फॉर एक्झाम्पल 70 डिग्री टू 80 डिग्री याच्यामध्येच व्हेरी होते एक्झाम्पल, त्या ठिकाणी आपण थर्मिस्टर यूज करू शकतो ते टेम्परेचर मेजर करण्यासाठी. As the temperature increases, the resistance goes down, and the decreases, the resistance goes up. Vice versa. जेव्हा टेम्परेचर इन्क्रीज होते तेव्हा रेजिस्टन्स डाऊन होते, आणि जेव्हा डिक्रीज होतं टेम्परेचर तेव्हा रेजिस्टन्स अप होते. इथं डायग्राम मध्ये ठीक आहे. त्यानंतर दिस इज द जस्ट अपोजिट टू द इफेक्ट ऑफ टेम्परेचर चेंजेस ऑन मेटल. या सेंटेन्स मला कोणाला सांगेल का? दिस इज जस्ट अपोजिट टू द इफेक्ट ऑफ टेम्परेचर चेंजेस ऑन मेटल. Opposite to the effect of temperature changes on metal.
Means sir, temperature is inversely proportional to resistance. Hello sir. Temperature inversely proportional to resistance.
Temperature inversely proportional to the resistance. Give me one example.
If temperature increases, resistance decreases.
This is finding temperature increase, resistance decreases, inversely proportional. This is clear. Give me one example related to this sentence. Opposite to the effect of temperature changes on metals. करंट कमी बर अपोजिट म्हणजे ट्रान्समिशन ऑफ करंट त्याचं कमी होतं, रेशो कमी होतो. टेम्परेचर इन्क्रीज झालं एन्व्हायरमेंटचं, सराउंडिंगचं. असं एखादं एक्झाम्पल. रियल लाइफ एग्जांपल, प्रॅक्टिकल बेस. तू त्या वायरला हात लावून बघितलंय का? हे विचारतो. किंवा आपण स्टील आणि कॉपर हे दोन्ही एन्व्हायरमेंट ठेवले. आता 11 ते 12 टेम्परेचर जास्त कुणाचं वाढेल? कॉपरचं का स्टीलचं? ऑब्वियसली स्टीलचं वाढणार, कॉपरचं कमी होणार, कमी असणार कम्पेअर टू द स्टील. Opposite to the effect of temperature changes on metals. Right. Then the sensitivity of temperature changes make the thermistor extremely useful for precision temperature. Underline precision temperature. What is meant by precision? Difference between accuracy and precision. झाले काय म्हणजे? Accuracy म्हणजे काय आणि precision म्हणजे काय? What is meant by accuracy? Accuracy म्हणजे काय? Yesterday, chief guest told all of you, you know all answers about throughout your syllabus or somewhat general type, general question, but you are not able to express yourself that manner. तुम्हाला सगळे आन्सर येत असतात, पण आपल्याला ते प्रेझेंट करता येत नाही, त्यामुळे आपलं सेशन होतं. आणि त्यांनी काल ही या गोष्टीमध्ये पण नोटीस केलं, हायलाइट केलं की जे होते त्यांना माहित आहे की तुम्ही तुमच्या थेरॉटिकल पेपरवरती किती मार्क करताय वगैरे, हे डझंट मॅटर. तुम्ही स्वतःला कसं एक्सप्रेस करताय तुमच्या गोष्टी, ते खूप महत्त्वाचं असतं. बरोबर, असं सांगतो तुम्ही. कम्युनिकेशन इज मोस्ट इम्पॉर्टंट. Then secondary your knowledge. म्हणजे असं नाही की नॉलेज नसेल तर चालतंय. सेकंडरी टाईप आहे नॉलेज. फर्स्ट तुम्हाला एक्सप्रेस करता आलं पाहिजे. ठीक आहे. ऍक्युरसी म्हणजे काय? ऍक्युरसी
Also related to constantness.
Someone said that related to constantness and approximately near to that value. accurate value. Then precision. Repetitions of accuracy. Repetitions of accurate value. It's called as precision. We are going to taking the number of readings with the help of vernier caliper. Like at pen time, we have to take the dimension of this pen. This dimension shows you 10 times. 10 point something, 10 point something, 10 point something. But the standard value is 10.5. Standard value is 10.5 and your measuring dimension is somewhat 10.4 point something, 10.4 point something. This is your accurate value and you are going to check this all parameters 10 divided by 10. It's called as precise value. This is nearest to or same as accurate value or standard value. Accuracy म्हणजे आपण जे डायमेन्शन घेतो ते आपलं जे बेसिक डायमेन्शन आहे स्टँडर्ड डायमेन्शन आहे त्याच्या रिलेटेड असतं सेम असतं त्याला आपण accurate म्हणतो. आणि ह्या सर्व accurate व्हॅल्यूचं कंपॅरिझन करून जे स्टँडर्ड व्हॅल्यू त्याचे प्रिसाइज व्हॅल्यू. It's called as precision. Precision temperature measurement, control and compensation in the temperature ranges from -100 degrees Celsius to 300 degrees Celsius, and they are essentially semiconductors which behave as resistors with a high negative temperature coefficient. Clear? Write down. Usually, when we raise temperature of metal, its conductivity decreases. Okay, Rishikesh, very good. Wait, still lecture going on. Why you are putting your roll number here?